name is Lee Gibbs, and today I will be discussing with you one of my favorite experiments called an ELISA. ELISA is an acronym for Enzyme Linked Immunosorbent Assay. This assay is one of my favorite experiments. One, it saved my dissertation project. I think that's probably the best reason why you should have a favorite experiment if it does that. And number two, it has clinical use in helping doctors to assess a diagnosis of a patient's disease by detecting a specific protein, or we will call it an antigen later on in this video, that is produced by this disease. So it's really important. The ELISA actually has wider applications now, as if you are a woman that wanted to know if you was pregnant or not, you would have used a modified ELISA that comes in the form of a pregnancy test. The pregnancy test, or the modified ELISA, actually detects an early stage pregnancy hormone that is produced when a woman is pregnant. So ELISAs have wide applications, and their use can be astronomical depending on the reliability of the assay, the sensitivity of the type of assay that you use, and how you actually perform the assay. So let's get into the most sensitive form of ELISA that we will be discussing briefly due to time constraints, which is called a sandwich ELISA. Yes, I said it, sandwich ELISA, as in the sandwich that you eat every day. And I'm not saying that to be funny. I actually want you to picture a sandwich. And that is very important. A lot of the meanings of a lot of experiments are right in the name. And this will help us to understand this enzyme-linked immunosorbent assay. What does all that mumbo jumbo mean? So let's just focus on the sandwich. So what do you need for a sandwich? You need, of course, a standard sandwich, not any fancy sandwich, but a standard sandwich, you need 2 pieces of bread, and you need your choice of a meat or cheese, but frankly, to just have a sandwich, you just need 2 pieces of bread, and you need a meat stuck right inside of it, and it sandwiches together. Voila. Chef Boyardee, you have your sandwich. Now, let's talk about what is an ELISA. An ELISA actually benefits from the interactions of an antibody and an antigen, or as we said earlier, the antibody and the protein. So the antibody, as we know from antibiotics, they actually bind to certain things in your system, certain proteins in your system, certain antigens in your system, and clears them out. So it has the ability to bind and actually lock, or if you actually know what an antibody looks like, bind and identify a certain antigen or protein based off how the protein, as we will say for this brief lecture, how it actually looks. So that will give you an idea of what's going on with this sandwich. So in this sandwich, what we're going to talk about is 2 antibodies and our protein of interest, or antigen, that's going to be wedged right in the middle. Okay, so have that idea. 2 antibodies, and you have an antigen that's right in the center that is going to allow the binding, the recognition of that certain protein that came from a disease. So let's put this, I like to actually put things in a real world application sense, but to better, get grips of what we're discussing here. So let us start off with this. You are a scientist, and you are doing a research project where you believe that your protein of interest, let's just say that it is let's just say your protein of interest, X. Protein X. They use that a lot on exams. So protein X. Protein X, you believe, can be used for a diagnostic, as a diagnostic protein, we can call it that, to actually identify a certain type of cancer. So you make a collaboration with a medical doctor and you receive all of these serum samples, and now you have, of course, in these serum samples a lot of different proteins. You know, a serum of blood sample, you will have millions to billions of proteins that's just going to be floating around. A lot of them may be yours, a lot of them are probably others. So we want to be able to discriminate between your protein and get the rest of those out of there, because we just want to detect your single protein. So what you will do is that you will coat the plates with what's called a capture antibody. And let's remember this sandwich, a capture antibody. The next step is what you would like to do is add your sample that hopefully, if you're right or if you're wrong, has your protein or will not have your protein. But hopefully, if your hypothesis is that you want to see your protein, I hope for all scientists that they see what they would like to see, as every PhD student dreams of. So you actually add your sample. Your capture antibody is only designed to recognize that single protein. Only that protein is specific for that protein. So your protein, if it's there, will bind to this capture antibody. And to increase the specificity of this ELISA, a second antibody will be used to bind, as we will say, on top of the antigen, and it will have what's called a enzyme. But for this, we'll say instead of an enzyme, let's say a flashlight that will basically be used for the brightness to say that this antibody actually detected your protein. So let's call it a detection antibody. That second antibody that's on top of that antigen, let's call it a detection antibody. And if you picture a detection, picture that you are in the midst of all this well with many proteins, and what you would like to do is be able to recognize this protein by this flashlight. It's going to be flashing towards you to say, hey, guess what, we have the protein here, we actually caught it. And now you have all these other proteins that are that actually did bind. If they did bind to your capture antibody, well, the more flashlights that are turned on, well, of course, for anybody, it gets really bright. So it gets the intensity increases of their light. So you will actually have to read this plate after you add your capture antibody, your sample, and then of course, your detection antibodies, we called it earlier, that will actually be read by a machine that detects absorbance, or if you think about the light, fluorescence. But really, it detects an absorbance of this enzyme that, when ignited by another chemical, it can show that, okay, we have more detection antibodies that's giving a higher, more absorbance, or a higher intensity. That means that we have more of the protein in this sample. On the contrary, if you have less antibodies that are binding detection antibodies, you will have a lesser intensity. You will have lesser flashlights going off, so you have lesser intensity. So therefore, you will have you would presume from this test that you would have you would assume from this test that you would have less protein in that sample. So that is actually what's called a sandwich ELISA, and that's what it's used for. So now they come in kits where they give very general protocols that are standardized for whichever protein that you're looking at. Now the application use has upgraded with the multiplex ELISA, that actually, when you get them, you can look at 12 different antibodies at one time, antigens at one time, to, let's just say, look at an inflammatory profile to say that all these cytokines or chemokines, or let's just say antigens that are produced, or proteins that's produced when you're under inflammation, they can be all looked at one time now in a certain ELISA kit. Also, you can have you could do other type of ELISAs, which there's two of them, which are called direct and indirect ELISA. Where in direct ELISA, instead of using the captured antibody, the only thing that you use is the detection antibody. And the indirect ELISA is more of competitive binding, where the uh, first antibody, primary antibody, will bind to the antigen, and the detection antibody will actually bind to the primary antibody, and you can detect that way also. But the benefit of using a sandwich ELISA is that it is up to 2 to 5 times more sensitive, and and also is more reliable than the other methods with direct and indirect. So hopefully that can explain the protocol, and give you a gist of what an ELISA is. It's been wonderful. Thank you. And hopefully my speeches will get much more better in time. Bye.